White paper. Ancient and AMP. Pre-industrial stored energy systems for modern resilient infrastructure integrating gravity, hydraulics, pneumatics, thermal mass and AMP. Mechanical inertia into contemporary sustainable cities prepared for. Global Robotics Corporation, Energy Research and AMP. Development Division Date 2025 Authoring AI. ChatGPT, Technical Research Assistant. Purpose. Document historically validated energy storage mechanisms requiring no batteries, revise them for modern cities, lunar, Mars habitats, and continuous industrial power systems. Executive Summary. Before chemical batteries became universal, civilizations developed durable energy storage architectures that could cycle for centuries with minimal resource consumption. These mechanisms, gravity reservoirs, flywheels, compressed air chambers, tidal basins, thermal mass structures, counterweights, and spring accumulators, operated through conservation of energy and gradual release. These systems store energy without conversion losses from electrochemistry, remain functional for decades to centuries, have repairable components using common materials, can operate with or without electricity. For future resilient cities, especially those facing energy intermittency, grid instability, or emergency sustainability requirements, these older methods offer load leveling, peak shaving, seasonal storage, critical system autonomy. They are especially suited for water systems, transportation, thermal conditioning, clockwork automation, mechanical energy buffering, industrial stabilization, underground, underwater cities, Mars and AMP, lunar bases, where chemical batteries degrade rapidly. These technologies are not replacements for renewables. Instead, they form long-life mechanical storage cores that smooth renewable variability and extend energy resilience during emergencies. Blank. Underscore. Blank. 2. Gravity-based storage. Elevated mass as a power reservoir. 2.1 Water towers and AMP. Raised reservoirs principle. Potential energy equals m times g times h. Raising water stores gravitational potential that later becomes hydraulic pressure. Historical use cases: Rome. Cisterns plus aqueduct gradients. Medieval towns. Water towers powering mills and AMP. Fountains. Early electrical grids. Reservoir-fed hydro turbines. Modern application. Continuous water pressure for firefighting and AMP. Hospitals. Microhydro-on-demand for remote settlements. Mechanical pumping plus gravity release cycles for robotic spaces. Blank. Underscore. Blank. 2.2 Massive weights and AMP. Counterweight systems. Examples: cathedrals and AMP. Civic clocks. Mineshaft hoisting systems. Counterbalanced elevators. Stone stack energy towers. Proto-gravity batteries. Relevance Today. Mechanical gravity batteries. Comparable to modern projects such as Energy Vault. Store excess renewable energy by lifting rocks, blocks during surplus generation. Release slowly to supply continuous mechanical or electrical output. Blank. Underscore. Blank. 3. Pneumatic storage. Compressed air as industrial muscle. 3.1 Compressed air caverns, tanks. Thousands of factories historically drove tools via air motors. Metalworking shops. Mines. Early automotive plants. Why it works now. No fuel risk in confined spaces. Direct mechanical drive for pumps, drills, conveyors. Long-term sealed storage. 3.2 Urban, Martian application. Underground air caverns allow seasonal storage. Waste heat. Right pointing arrow. Air compression. Right pointing arrow. Stored air. Right pointing arrow. Winter release. Integration with hydraulic systems equals hybrid pneumatic-hydraulic grids. Blank. Underscore. Blank. 4. Flywheels. Mechanical batteries with extreme longevity. 4.1 Ancient and AMP. Industrial roots. Egyptian grain grinders. Early inertial accumulation. 18th–19th century textile mills to smooth intermittent steam strokes. Railway workshops and machine tooling. Early vehicles and marine engines. 4.2 Modern application flywheel banks. Absorb load shocks. Release when demand peaks. Stabilize microgrids. Materials. stone right pointing arrow, cast iron right pointing arrow, steel right pointing arrow, carbon fiber design improvements, magnetic bearings remove friction, vacuum housings reduce drag, carbon rings resist tensile failure, blank, underscore, blank. 5. Tidal and AMP. Sluice Systems. Lunar-Driven Recurring Storage 5.1 Old World Precedents, Brittany and AMP. Wales. Tidal mills using controlled floodgates, East Asia. Sluice channels with water traps, North America. Clam gate mechanisms 5.2 operation. 1. Gate opens at high tide, right pointing arrow fills basin. 2. Gate closes, right pointing arrow, energy stored as contained water. 3. Gate opens to power wheel, turbine as tide falls. Benefits: predictable cycles, centuries of operation, nearly no mechanical electrical conversions, blank, underscore, blank. 6. Thermal mass storage. Stones, masonry, salt, clay 6.1 masonry heaters and AMP. Roman hypocausts, rock or brick accumulates heat. Burn high and AMP. Fast right pointing arrow store heat. Release slowly across hours or days. Uses: residential warming, industrial drying, greenhouses, underground cities. Application: store solar excess heat, stabilize ambient temperatures, buffer intermittent renewables, blank, underscore, blank. 7. Springs and AMP. Mechanical accumulators 7.1 elastic storage springs and torsion systems. Harrison maritime chronometers, early automata, wind-up radio and AMP. Torches 7.2 engineering benefit, extreme cycle life. Millions of cycles, predictable release curves. Modern extensions. Torsion spring elevators, mechanical robots with muscle storage. Blank, underscore, blank. 8. Application to future cities, Earth, Moon, Mars. Need stored energy solution. Notes: peak shaving and AMP. Grid smoothing flywheel stacks plus counterweights. Long lifetime. High cycling thermal conditioning. Masonry, salts, clay. Mars. Thermal mass doubles as radiation shielding. Water pressure autonomy. Raised reservoirs supports fire safety and AMP. Hospitals mechanical energy backup. Compressed air banks safe in oxygen limited environments. Energy for agriculture. Tidal, reused hydraulic gradients. Irrigation plus pumping cycles. Transportation lifts counterweights plus air pressure. No electricity required to move bulk loads. Emergency resilience. Gravity plus flywheels plus pneumatics keep life support running during outages, blank, underscore, blank. 9. Integration with modern renewables. These systems form base load buffering beneath solar photovoltaics, wind turbines, geothermal wells, small hydro, hydrogen electrolysis. They convert intermittent renewable surplus into century-scale stability. Blank, underscore, blank. 10. Recommendations for Global Robotics Corp. 1. Prototype a gravity flywheel air hybrid unit for workshop power. 2. Develop modular city energy cores using masonry plus thermal mass. 3. Map municipal water networks for microhydro extraction points. 4. Integrate counterweight elevators into new urban design. 5. Create an automated sluice gate tidal demo site for market visibility. 6. Publish field manuals for O gravity batteries, O flywheel banks, O pneumatic storage, O masonry heat banks, blank, underscore, blank. 11. Strategic value. These systems reduce dependency on lithium supply chains, offer geopolitical insulation, create energy storage without batteries, leverage heritage engineering with modern material science. They position future cities and Mars bases to operate indefinitely even if electronics fail, making them a critical layer in civilizational resilience. Blank, underscore, blank. 12. Closing statement. Stored mechanical energy is humanity's most durable infrastructure. Batteries degrade. Electronics fail. Gravity, mass, pressure, inertia, and heat endure. Integrating ancient proven mechanisms with modern materials gives Global Robotics Corporation a unique path toward 100-year energy autonomy, fulfilling both engineering reliability and strategic independence while enabling off-Earth colonization without fragile grid assumptions. Global Robotics Corporation.